Good morning. I, Sharvan Kumar, Assistant Professor, Department of Computer Science and Engineering, Akgec Garg Engineering College. So, today I am going to discuss very important topic. The topic name is dynamic memory allocation. That is, we will cover in C. So, we will cover its program also at the end, and we will discuss what is the meaning of dynamic memory allocation. Also, we will discuss about the difference between static memory allocation and dynamic memory allocation. Next, we will discuss about various functions that include in dynamic memory allocation, and also we will see examples and as well as its program. So, let us start. First of all, what is the meaning of memory allocation? So, memory allocation says memory allocation is allocating a portion of memory for storing data during program execution. So, there are two types of memory allocation C. One is static memory allocation and second is dynamic memory allocation. So, as we are storing our data or program for execution, the memory stored in the stack. So, in that stack we deal with the static type of memory, means size and range are going to be size is going to be defined at the compile time, and at the run time we are not going to change it. And if I talk about the dynamic memory allocation, that belongs to a dynamic way, so that will be stored in heap. If we are talking about C++ or Java, where objects are created, in that case they are created in the heap and we already know about it. But as we are using this dynamic memory allocation C, so the heap will store the pointers as well as the dynamic memory for our various type of data structures like linked list and other kind of things we will use with the dynamic memory allocation. And our we can say our variables or functions that will be stored on the static data memory. So, I created here two diagrams. One is static memory and second is dynamic memory. So, dynamic memory contains runtime stack, static data memory and instructions, and dynamic memory that store data on the heap. So, next, what is the meaning of now static memory allocation? As I earlier discussed with you, static memory allocation is a method of reserving memory for variables and data structures when program is compiled. So, the memory is allocated before the program runs and the size and location of the memory block are already fixed. So, the compiler allocate memory address of variable address to the variable during the compilation, and the allocated memory remain constant throughout the program execution, and the memory automatically freed when the program ends, and no user is going to be free that memory. Automatically it is allocated and automatically it is deallocated. So, advantage of static memory allocation is it is very fast and simple, and also it avoid memory fragmentation, reduce the risk of memory leakage and all kind of things. So, the basic disadvantage of static memory allocation is that it is inflexible and wasteful. So, also it limits the scalability and modularity of the program. Suppose I created an array, that is the example of static memory allocation, and I given the value for the size. Suppose I created an array of 100 elements. In that 100 element, if I am going to fill the element up to suppose 20 or 30 elements in that array, my remaining values remaining location will be wasteful. And suppose if I want to increase that size of the array, in case of new elements are going to be added, in that case I can't change that size. But in case of dynamic memory allocation, I can do all kind of things. So dynamic memory allocation refer to the ability to allocate and deallocate memory during the runtime of the program. This is in contrast to static memory allocation, where the memory is allocated at the compile time. So dynamic memory allocated during the runtime of the program. So advantage of dynamic memory allocation is, first is flexibility. So dynamic memory allocation allow us to adjust the amount of memory our program uses based on the program needed during the execution. So this is crucial when we don't know the required memory size beforehand. When dealing with the user input or variable data structures, we can do we will use dynamic memory allocation. Second thing is efficiency. We can allocate memory only when needed and release when no longer we required it. So if I talk about the difference between static and dynamic memory allocation, that always asked in the exam. So if I talk about the static memory allocation, memory is allocated before the execution, means at the compile time. The program begins during the compilation. So in case of dynamic memory allocation, memory is allocated during the execution of the program. Second, no memory allocation or deallocation are performed during the execution, but in case of dynamic memory allocation, memory binds are established and destroyed during the execution. Next, variables remain permanently allocated, and in case of dynamic memory allocation, allocated only when program unit is active. Fourth thing is implemented using stack and heaps, while the dynamic memory allocation implement using data segment as well as heap. Next, static memory allocation. In static memory allocation, pointer is needed to access the variable, but in dynamic memory allocation, no need of dynamic allocated pointer. Next, static memory allocation is faster compared to dynamic, where dynamic memory allocation has one disadvantage, that is slower execution than static. So in case of static memory allocation, more space is required, while in case of dynamic memory allocation, less space are required. Only the disadvantage with with dynamic memory allocation is it is slower than the static one. Rest of the all we get the advantage of dynamic memory allocation, and we will frequently use in the data structures also. Next, we are talking about the functions of dynamic memory allocation. So the dynamic memory allocation can be achieved using the following functions that are included in stdlib.h header files. So there are four functions we will discuss here. First is MALLOC, which means the memory allocation, which allocate a single block of memory, single block. If I talk about the CALLOC means contiguous memory allocation, which allocate multiple block of memory of same sizes. Also, if I talk about the free means freeing the memory. As we are allocated the memory, it is our responsibility to deallocate the memory. In case of static memory allocation, we don't require to deallocate the memory because it automatically done. But while in dynamic memory allocation, free function will be called and the dynamic memory allocation will be removed. If I talk about the last function, that is realloc, realloc says reallocation of memory. If I want to increase or decrease the size of the memory at the runtime, I can do it using the realloc function, whether it can be allocated by MALLOC or it can be using by CALLOC. I can change the size as well as change the number of blocks in the using realloc function. First, so we talk about first function, that is MALLOC function. MALLOC means memory allocation. So first thing, a block of memory can be allocated using the function MALLOC. Also, the reserved block of memory specified size and return type of the type, that is of void, means void type is of return type. So the return pointer can be typecasted to any pointer. So general format is here type star p. Next, we are talking about p equal to cast type pointer as well as MALLOC. Next, number of elements we are going to use and the size of each element. So that will be, we can use it also cast type, malloc, and size of data type, or we can say number of element. Automatically that particular size is allocated. Next, if I talk about this example, as we see in the syntax, here the p pointer is p is integer type of malloc, and there are 100 number of elements of size integer, because each integer are taking 4 byte in new compiler. So the total size will be 400 bytes will be reserved, but that are not actually reserved. When we are going to use that, that number of element will be reserved. So a memory space equivalent to 100 times the size of int byte is reserved. So the address of the first byte of the allocated memory is assigned to the pointer p of type int. So 400 byte of space will be reserved. So same as we are talk about, as we created our malloc using integer, we can create using character also. So here character type pointer equal to char malloc 20. So it will allocate 20 bytes of space for pointer CP of C pointer of type character. If I talk about any other type of data type, then we are using user defined data type. User defined data type means structure. So structure type pointer equal to structure student malloc 10 into size of the structure of the student. So allocate space for the structure array of 10 element. SPTR point to the structure element of type structure student. One important thing to be noted, always use size of operator to find the number of bytes for the data type, as it can vary from machine to machine. Because earlier, if I talk about the older compiler, it takes 2 bytes, and in case of new compiler, integer takes 4 bytes. So we always use size of operator to allocate to define the number of bytes to be used, means how much size it is going to be taken. Next, if important point to be noted, malloc always allocate block of contiguous byte. So the allocation can fail if sufficient contiguous memory space is not available. So if it fails, malloc return null. So here we are going to check if p pointer p integer malloc size of this equal to null. In that case, memory can't be allocated, because that particular size is not available in the memory. In that case, it will return null. So if that is null, we cannot allocate the memory, and we are going to exit that. So that is a simple snippet to define that malloc. Next, we are using malloc type of array, means dynamic type of array. Till now we have studied about static type of memory or static type of array. We are talking about now dynamic type of array. Once the memory is allocated, it can be used with pointer as or with array notations also. So how we are going to use it? Integer pointer p and I. So we are taking the number of elements, p equal to integer type of malloc n into size of int. So for I equal to 0 to n, so what I take here, I take array of p of I. So the n integer allocate can be accessed either by this way, 0 element, 1 element, 2 element up to n minus 1, or we just as p0, p1, p2 up to p n minus 1. Either by this way or by this way. Next, that is the example of using malloc. Here in this example, there are two variables are given, I and n, also float, height. Here float, sum, average. We are calculating the average height of the students in this example. So we taking the number of students n. So height equal to float malloc n into size of float. Also, now we are going to input for the heights of all the students in an array. Now if I going to sum those array, in that case for I 0 to n, sum equal to, because sum equal to 0, each element will be sum will be added with sum. So average will be sum divided by float of n. So average height will be average, we are going to get here, and we are going to print that array, print the average value. Now we use free function. As we are going to allocate the size, we are going to free that element. Next, we are talking about the free function. Free function is going to release the allocated space, and allocated block can be returned to the system for future by using free function. So general syntax is free PTR, where PTR is the pointer to the memory block which has been previously created using the either malloc or calloc. Also, no size needed to be mentioned for the allocated block. The system remember it for each pointer to be returned. So no size is going to be mentioned with that pointer. Free automatically deallocate the memory space. Next, we are talking about the calloc. Calloc means contiguous memory location. Contiguous, that is also standard library function in C, which include in stdlib.h. So that is used for dynamic memory allocation. It is similar to the malloc, but with two key differences. The first difference is initialization, and second is in argument. If I talk about the initialization, calloc initialize the allocated memory to 0, but in case of malloc, it takes the content are undefined, means garbage value will be there. Also the argument, calloc takes 2 argument, while in case of malloc it takes only one element, one argument, that is total number of byte of the allocated. So the function signature or syntax will be void calloc number of element and size of data type. But in if I talk about malloc, it takes only one element, one argument. Here it takes 2 argument. So num is the number of element of the allocated, size is the size of each element of the byte, return value will be the return pointer beginning of the allocated memory. If allocation fail, similar to that thing, it return null. Same it was in the malloc, it return null. If I talk about the syntax as well as its diagram, so here is the syntax where the cast type calloc number of block into size of data type. Here how it is going to be created, the number the size of this one is of 4 byte, that is of 4 byte, and number of elements, number of block are going to take 5. So the total value will be 20. In case of this one malloc, you will see 40 contiguous space will be there, but in case of calloc, what it takes 4 is the size of the block and total element will be 5. So total will be 20 blocks, 20 bytes of memory will be stored. So calloc is contiguous memory allocation. It is used to dynamically allocate specified number of blocks of the memory and specified type. Also it will be used with array, most important thing. Next we are talking about realloc. Realloc means reallocating memory location. Reallocate means it is a library function in C which include in the stdlib library. It stands for reallocation of memory, which is used to change the size of dynamically allocated memory. It resize the current memory block without changing its original content. We are not going to change the original content. We can increase or decrease the size of the memory. One important point to be noted here, that it is considered that reallocation is used in case of dynamically allocated memory only. But if memory allocated is not dynamic, then behavior will be undefined. Important point to be noted here, only realloc will work with malloc or calloc if memory is allocated using malloc or calloc. Next, dynamically allocated memory is the process of assigning the memory space during the execution time or at the run time. So the general syntax for realloc is void realloc, void pointer earlier and the size of new pointer. So the function need 2 argument, a pointer that point to the beginning of the memory block which we want to resize. Second is the size that represent the new size of the block, that is in the byte, where the size t is just an alias of unsigned int defined in the library of C. So the new block can be smaller or larger. We can increase or decrease both way with the original block. So that is the syntax for reloc. Reloc integer pointer. Here the malloc give 5 5 elements of size int, means total 20 elements will be 20 bytes of memory is be allocated. But with allocate with reallocate, we allocate with 10 with new size, that is 10. So the now element will now the pointer will contain 40 byte of memory. So that is the major difference between malloc, calloc and reloc and free. You will see all these things. I am using these single program where I will use the function malloc, calloc, reloc and free, all in the same program. In first execution, I will demonstrate about malloc function as well as reloc function. In second part, I will again allocate and relocate using calloc. So see here, you will see here integer ptr, that a pointer will be declared. Next n and I, two variables I am going to take. So first I am talking about the number of size of the array I want to create, n. Next pointer equal to integer malloc n into size of the int, as I earlier told in the syntax. Now I am going to create a array of what? ptr. Next I am going to print that array, take the value of the array and now going to print that array. Here again I am going to resize the array using reloc pointer with new size. Here I am taking for reloc function, again new size is going to be mentioned here. I will use reloc function pointer with number of size. Here the pointer will be the again I am going to print that thing and use that thing. Last, free the memory allocated using malloc. Now see the result. I am taking 5 elements, given the elements 1, 2, 3, 4, 5. Now it asks for resize that particular array. Suppose I am going to decrease the size, decrease the number of element. I am giving 3. Now 9, 8, 7. You will see earlier the array size was containing 5 elements. Now it contains 3 elements. Same program we will do with calloc function. Everything is same as it was in malloc. The only difference is we are using CALLOC here. So no error is there. We are going to execute. So I take 5 elements initially. First element 23, 33, 43, 53 and 63, 73. Now I want for excuse me, 5 elements. 5 elements 23, 33, 43, 45, 56 and 78. Now new size is going to be as I am now increasing the size. Suppose I increase with 7 elements. 1, 1, 2, 2, 3, 3, 4. You will see here. Now earlier size was 5. Now using realloc, its size is 7. So that is the demonstration of MALLOC, CALLOC and realloc. Thank you very much.